What's up, everybody? This is EchoLynx. Today we're going over the Linux Fundamentals Part 2 room from TryHackMe. If you haven't completed Linux Fundamentals Part 1, do that first. It covers the initial basic commands and preps you for this room. Task 1 is an introduction. It reminds you to complete Part 1, outlines the goals for this room, and explains what we'll walk through. Read it and hit complete. That finishes Task 1. Next is Task 2, accessing your Linux machine using SSH. In Part 1, we used the in-browser connection to drop you straight into a Linux box with zero setup. That used the very same protocol we're using today. Secure Shell, or SSH. SSH is an encrypted way for one device to talk to another device's command line over a network. Your input is scrambled in transit and only unscrambled on the other side, so you can safely send commands across the internet without anyone snooping on what you type. For this task, you'll deploy two machines, your Linux target and the TryHackMe AttackBox. First, press the green Start Machine button in the task to spin up your Linux machine. At the top of the page, you'll see deployment info with an IP address. This is the address you'll log into via SSH, so make a note of it. Next, click Start AttackBox at the top of the page to launch the TryHackMe AttackBox. It's an Ubuntu Linux machine hosted in the cloud that runs right in your browser, and you'll use it to connect to the target you just started. SSH is simple to use. You only need two things: the target's IP address and valid credentials on that target. For this room, the username is TryHackMe and the password is TryHackMe. On the AttackBox desktop, open the Terminal app. In the terminal, type the SSH command using the username, an @ and the IP address shown at the top of the room, like this: sh TryHackMe at 10.10.95.246. For you can be different, so replace 10.10.81.11 with the exact address of your Linux machine. The first time you connect, SSH will ask you to confirm you trust this host. Type yes. It will then prompt for the password, enter TryHackMe, and press enter. You won't see any characters appear while you type the password. That's normal. Just finish typing and hit enter. Once you're in, your prompt will show you're on the remote machine. For example, TryHackMe at Linux 2. From this point on, every command you run is executing on the target, not on the attack box. Read through the SSH notes in the room to cement the idea. Make sure you're logged in, then click Complete to finish, Task 2. The checkpoint that says, I've logged into the Linux Fundamentals Part 2 machine using SSH requires no answer. Just mark it complete and move on to Task 3. Task number 3, Introduction to Flags and Switches. Flags, also called switches or options, are extra arguments you add to a command to change what it does. By default, a command runs with its standard behavior. For example, ls lists the contents of your current directory, but it hides anything whose name starts with a dot. If you add a flag, you can extend that behavior. Running ls short for --all, includes hidden entries like .hidden folder, so you'll see more than just folder 1. Most commands that accept flags also support a quick help screen. ls-help prints a formatted summary of options and short descriptions of what each one does. You'll see pairs like -a, -all, and many others. This help output mirrors what you'll find in the manual man pages, which are the built-in documentation for Linux commands and applications. To read a manual page, type man followed by the command name, for example, man ls. The man page opens in a pager so you can scroll and read. Use the arrow keys to move around. The down arrow scrolls down the page and Q quits when you're done. Inside the man page for ls, you'll find the same options with more detail. One you'll use a lot is -h, short for --human-readable, which prints sizes in a friendly format. Explore man ls to get comfortable with navigation, then answer the questions. The directional key to move down is the down arrow. The flag for human-readable sizes is -h. When you've tried a few man pages and you're comfortable with the flow, Submit your answers and move on to Task 4. Task number 4. File system interaction continued. You've already used ls, find, and cd to explore and navigate. Now we'll round out the essentials so you can create, move, copy, and remove things, and quickly identify what a file actually is without leaving the terminal. Creating files and folders is straightforward. Use touch with the name you want to create a blank file. Touch note. Use mkdir with the name you want to create a new directory. mkdir my directory. Remember that touch only makes an empty file. You add content later with something like echo hi greater than note, or by opening an editor such as Nano. Removing is just as simple. rmnote deletes a file. If you need to remove a directory and everything inside it, add the recursive flag, rm-r my directory. That tells RM to descend into the folder and delete its contents before removing the directory itself. Copying and moving are your day-to-day workhorses. CP takes 2 arguments, the existing file first, then the new name or location, and makes a duplicate. For example, CP note2 creates a second file with the same contents. MV also takes 2 arguments, but instead of duplicating, it renames or relocates. MV note2 note3 renames note2 to note3. You can also move into a folder with MV myfile myfolder, after which ls myfolder will show myfile living there. When extensions lie or are missing, ask the system directly. The file command inspects a file and reports what it actually is. Run file note and you'll see something like note. ASCII text once you've added content. Before that, it may report the file as empty. Use cat to read contents quickly. Echo hi greater than note, then cat note will print hi. Pro tip. Just like with cat, these commands happily accept full paths, so seep directory 1/directory 2/note, ~~ backup /note works fine, even if you're not currently inside those folders. For the questions, here's exactly what you need. To create a file named new note, run touch new note. On the deployable machine, run file syn the TryHackMe home directory to see its type. You'll get ASCII text. To move my file into my folder, run mv myfile myfolder. After moving, cat myfolder myfile reveals the flag. Submit the value you see, for example, thm file system. When you're done, mark the Continue to apply your knowledge. Checkpoint complete and head to Task 5. Permissions. Task number 5. Permissions 101. By now, you've probably noticed that some users can open certain files or folders while others can't. Linux controls this with permissions, which you can read at a glance using the long listing view. Run ls lh in a directory and you'll see output like rw, r, 1 cmnatic 0, February 19th, 1037 file 1. Don't worry about every column. Focus on the permission string at the start and the owner and group that follow. The permission string is read from left to right as 3 triplets. Read R, write W, and execute X for the owner, then for the group, then for everyone else. A leading dash means a regular file. A leading D means a directory. In the example above, the owner can read and write. The group can read. Others can read. Linux lets you be very granular. A single user can own a file, while a group can be given its own set of rights to that same file. Handy in real life for things like web hosting, where the web server's system user needs read/write access for the app to work. But customers must be able to upload their site files without becoming that system user. Sometimes you need to become another user to read a file or perform an action. The su command switches accounts. You need the username you're switching to and that user's password. If you just run su user2, you'll become user2, but stay in your current working directory and keep much of your previous environment. If you run su-l user2 or su-login user2, you'll start a true login shell for that user. You inherit their environment and you're dropped into their home directory. If you're curious about other switches, like running a single command or choosing a shell, open the manual with mansu. For the questions, on the deployable machine, check the owner of the file named important with ls-l important. The owner is user2. To switch to that account, use su user2 and provide the password user2 when prompted. The Switch Now checkpoint doesn't require an answer, just do it. Once you're user2, print the contents of important with cat important and submit the flag exactly as shown on your machine. It will follow the usual THMC format. After that, mark the task complete and move on. Now for task 6, common directories. /etc holds system configuration, files like sudoers, passwd, and shadow, password hashes. /var stores variable data used by services, especially logs inside /var/log. /root is the root user's home directory. /tmp is temporary space that's cleared on reboot, perfect for quick scratch files or enumeration scripts. On the box, you can confirm these quickly. What is the directory path that we would expect logs to be stored in? /varlog.what root directory is similar to how RAM on a computer works. /tmp. Name the home directory of the root user. /root. Now apply your learning and navigate through these directories on the deployed Linux machine. No answer needed. Task 7 is a recap. You used SSH, learned flags/switches and man pages, practiced file system commands, and got a primer on permissions and common directories. No answers here. Just click Complete. Task 8 points you to Part 3. First, terminate the machine you started in Task 2 so you don't leave it running. Then hit the link to Linux Fundamentals. Part 3, join the room and you're set. No answers. Click Complete on both.